Let's start learning with iDigitalpreneur. Now, in this video, we'll start off with the concept of CSS Flex, and we will see how we can use the concepts of Flexbox to kind of create complicated layouts in our web page. So let us get started. Now, the entire concept of Flex revolves around the fact that if there are multiple elements or multiple items inside of a container, so here I have a div with a class of parent, and inside of the div I have a couple of elements, and right now the visual output is looking like this. If I want to align these items, or I want to alter the position of the items, but I want to do it dynamically, that is without even knowing the width and the height of the actual child elements, that is these divs, without even knowing them, the browser automatically calculates the space it will require, or all of the child elements will require to be placed inside of the container HTML element. So Flexbox is ideally used to align items inside of a container and distribute spaces amongst the items even when the width and the height of the child elements are not known. So here I have three divs with inside of a class of parent, inside of a div with a class of parent, and I've given some basic styles to both of my parent and my child. Now the first step to instantiate Flex is to apply a display property to my parent container. Mind you that the display of flex property always needs to be on the parent container and not on the child container. If you provide this display flex on the child container, it will not work. So once I do this inside of my parent and I go back, now you can see that the layout of my child elements, all of the three divs, that has changed, and now they are coming right next to each other. This is the default intended behavior of Flex, because now the browser is ready to align the child items as per the space available inside of the parent container using all of the different Flex alignment properties that we are going to see right now. So the first property that we're going to look at is something called flex direction. Now flex direction has a couple of predefined values: column, column reverse, row, and row reverse. By default, the value of flex direction is row, but you can change it to column, row reverse, and column reverse. What essentially flex direction does is that it changes the main axis and the cross axis. Now, what do I mean by the main axis and the cross axis? So anytime you define a container with a display property of flex, the horizontal axis or the x-axis is considered to be the main axis, and the vertical or the y-axis is known as the cross axis. So using the flex direction property, you can control which particular axis, whether it's the x-axis or the y-axis, which particular axis needs to be the main axis. So when its value is row, the main axis is defined as the x-axis, the horizontal one, whilst the vertical or the y-axis is called the cross axis. Now I can change this to column, and column will uh, make everything to be opposite. That means the main axis now becomes the vertical axis, whereas the cross axis becomes the horizontal axis, and this will kind of change how the elements are aligned. By default, because the flex direction is row, the elements are aligned on the main axis, which is what we were seeing right now, that all of my three divs were aligned on the main axis, that is the horizontal axis, and I can control that flex direction using row, column, row reverse, and column reverse. Row reverse and column reverse actually works with another concept of flex wrap, which we will see just in a moment, but flex direction is essentially used to control, or rather toggle, the main axis and the cross axis. The next property that we are going to see is something called flex wrap. And flex wrap is essentially one of the properties which allows the elements to be wrapped onto the next line. So because we know that Flexbox, in Flexbox, the space is dynamically allocated to all of the child elements, there will come a point when no more child elements can be fitted inside of the container, and that will lead to a case of overflow. So just to visualize this, what I'm going to do is I'm going to go back to my index.html and I'm going to create more child elements inside of my parent, probably something like this, and let's make it quite a huge one. And now you can see that the browser tried its level best to accommodate each and every child on the main axis, but because of the sheer amount of child elements inside of my parent, there came a point where it was no longer possible for the container to hold the child elements, which led to the case of overflow, which you can see right now. Now, this is the default intended behavior of Flex. Let us say you don't want this behavior. You can control this with a property called Flex Wrap, and by default it is set to no wrap, but you can set its value to wrap. And now you can see that the moment the space on the single line it fills up and there are still more child elements left, the child elements kind of wrap onto the next child and wrap onto the next line, and then the child elements are laid across the main axis of the next line. This is what flex wrap does, and if you change this back to no wrap, it will go back to the overflow scenario which we just saw. Similar to this, we have something called wrap reverse, which will change the order of the wrapping. So for this example, I'm going to show you what this means. So child 3, now essentially the bottommost elements inside of my DOM flow, which are these childs, these will come at the very top. Meanwhile, the first elements will be at the very bottom, which is what is visible here. So basically it changes the order of precedence of the HTML elements. Now the next property that we are going to see is something called flex grow. Now flex grow is basically the amount with which the element grows inside of the container. By default, the flex grow value is set to 0. That means, let me go back and remove all of these childs because we don't require them anymore. So I will remove these childs. Now by default, these child elements don't tend to take up the entire space inside of the container because the value of flex grow is equal to 0. Now if I change this to 1 and flex grow needs to be on the child element. This is for individual child elements, not the parent element. If you change this to be 1, you will see that each child grows to a value of 1. That means the only possible values are positive numbers 0, 1, 2 and 3, and that basically shows the rate with which the element should grow, and it should take up the space inside of my parent container. So by default the value was 0. I change this to 1 and now the child tends to take up all of the space present inside of my container, which is what is happening here. Now if I want that one of the child tends to take up more space than the rest of the child, for example I want my child 2 to have more growth inside of my container, I can target that particular child. I will say child 2 and I will set its flex grow value to be greater than 1 because that is what is for all of my child elements, but I want this child to grow even much more greater than all of the remaining childs. So I will do flex grow of 2, and now you can see that child 2 is taking up more space. It is growing at a much faster rate than the remaining child 1 and child 3. So this is what flex grow is about. If you want that the child elements take up the entire space inside of the container, you set its value to flex grow. Now, similar to flex grow, we have another property called flex shrink, which is the opposite of flex grow. It basically shows the rate with which the element should start shrinking. So by default, the flex shrink value is set to 1, and you can set it to 0 or you can set it to some higher value so that the element will actually start shrinking inside of the container at a much faster rate. So let's say for my child 2, I want the flex shrink to have a value of 2, and now because of available space. Let's add more spaces here. Let's add more children, in fact. Now, when I'm saying flex shrink to be 1 or 2, the child elements, the second child will actually shrink faster than the remaining of the child. And to kind of visualize this, you can go into the dev tools and you can start shrinking the screen size, and now you will see that child 2 is shrinking at a much faster rate than child 3 and child 1. So this is what flex shrink and flex grow is all about. Now the next property that we are going to see is actually the alignment, the different alignments that are available as part of my display flex. So inside of my parent, I can go ahead and type in justify content, and justify content takes in a couple of different values, and justify content is used to align the child elements on the main axis. There are different alignments which are available as part of the flex specification. We will see what those different values are and how it actually helps aligning the child elements across the main axis. So by default, the value for justify content is flex start, which is what is visible here, that all of my child elements begin at the start of my main axis. The start of my main axis is nothing but the start of my uh, container, the start of my parent container, and because I've given it a padding, the main axis starts from this particular point and it goes to the end of the parent container. Now another property which is flex end, which is the opposite of flex start, and it will move all of my child elements to the end of my main axis, and that is what is happening here. If you want to move all of my child, and all of the space calculations are actually being done by the browser. We are not specifying the width and the height of the different child elements. All of these calculations internally are being done by the browser. So flex end moves all of the child elements to the end of my main axis. Similarly, I have something called center, and this does exactly what it looks like. It centers all of my child elements at the center of the main axis. So even if I start adding in more child elements, all of my child elements will be at the dead center of my main axis. This is what justify content of center does. Now let's remove some childs from here, and let's now see more justify content values. The first one being space evenly. Now the moment I do space evenly, you will see that these child elements are taking up even spaces amongst them. So the space between the start of the container and the first child, and the space between child 1 and child 2 and child 3 and child 3 and child 4 are evenly spaced. That means space evenly spaces the children out evenly across them, with all of these spaces taking up equal dimensions. And this will continue even if I'm decreasing the screen size. Because of space evenly, the space between all of the child elements and the border of the parent are always going to be equal. This is what space evenly does. Now moving on to the next property, that is space between. And space between is a little different owing to the fact that the first child element and the last child element of my flex parent, they are moved to the start and end of my main axis, which is what is visible here. Child 1 is at the start of my main axis, whereas child 4 is at the end of my main axis. And then all of the other child elements coming in between of the first child and the last child, they are evenly spaced. That means the space between child 1 and child 2 and child 3 and child 3 and child 4, they will be evenly spaced. So it is a combination of space evenly with the first and the last child moving towards the extremes of my parent container. That is what space between does. And in most of the layouts that we do today in the modern web, you will find a huge use case for space evenly and space between. Now, finally, there is one another value which is called space around, and space around is a little complicated and it does not find a lot of use cases in actual website designing, owing to the fact that now the children are spaced in a different manner. Now, we'll see how the spacing is done. So, the browser actually calculates the width and the height of the individual child elements, and it also calculates the width and height of the parent container, and it starts to place the child elements in such a way that the leftmost border of the container and the first child element, let's say the distance between these two has a value of x. Similarly, the last child and the last border or the end of my parent container, the distance between them is also x, and all of the other spacing between the individual child elements is 2x. That means this is x, this is x, and now this value and this value and this value, these are 2x the space. That means twice the space what is available here and here. This is what space around us, and this is maintained, this is maintained till the very end, and it will keep on maintaining till the point it is no longer able to accommodate all of these four child with the given width and height of the container, and at that point of time overflow will start happening. To kind of make sure that you don't run into overflow issues, you should always put a flex wrap and give it a value of wrap, so that the moment the space actually goes less, the child elements are actually coming in the next line, because there are less number of children here, so flex wrap is not working. But let's add more child elements and see how flex wrap would work. So flex wrap will not work with space around. So this was all about justify content. Similarly to justify content, we have another called align items. And for align items, let me give up a height of, let's say, 500 pixels. And now you can see that the divs are actually taking up the vertical space, and they're trying to fill up the vertical space that is present inside of my container. This is the intended behavior of flex, because as we mentioned that flex tries to take up all of the space inside of the parent container, even if it means taking up vertical spaces. To kind of tackle this, we have another property called align items, and you can give it all the values which you gave for justify content. So let's start with flex start, and now you will see that flex start is actually moving all of the elements to the start of the cross axis. So you can consider align items to be the justify content for the cross axis, like the way elements were getting aligned on the main axis for justify content. Now elements are getting aligned on the cross axis. Similarly, flex end for align items will move all of the elements to the end of my cross axis, which is the vertical one. And I can also do center, and it will move all of the elements to the center of my cross axis. Similarly, there are space around, space between, and space evenly. Now space around won't work because the vertical spacing of all of the elements are not there yet, because there are less number of child elements. If I increase the number of child elements inside of my parent container, we can lead to a situation where there is wrapping going around. So align items for space around, space evenly, and space between only works if you have flex wrap to be wrapped. And now you can see that space around it actually tries its level best to create spaces on the cross axis. Owing to the fact that there are a lot of number of child elements inside of the container, we are getting this sort of a result. But ideally, align items are used to move the elements across the cross axis. And finally, we have one another property called align content, which is different from align items, owing to the fact that these items only work when you have flex wrap to be wrapped. That means this will not work with no wrap, it will work with wrap. And align items actually moves all of the wrapped up child elements across the cross axis. So here I said space around, I can do space between, and it will work exactly how justify content was working. exactly how justify content was working, but on the cross axis. So justify content and align content are just two the same thing on different axes. Now there is yet another property available inside of Flex, which is the order property, and the order property is applied on the child element itself. It is used to specify the order in which a particular Flex child element should occur. So for example, let us say that I have 4 child elements here: child 1, child 2, child 3, and child 4. But now I give my child 2 a order of 2, and now you can see that my child 2 is coming at the end of my container. But even though that child 2 is the second element of my parent container, this is still coming at the end of my parent container because I gave it an order greater than 0. So by default, every flex child element has a value order of 0, and that means it will respect the order which comes inside of my HTML document. But in case you want to alter the order of these child elements, you can start giving them some values other than order, other than 0. So for child 2, let's say I give it an order of 1. So because all of my other child elements have an order of 0, they will come first, and because my child 2 has an order of 1, it will come at the very end. Similar to this, let's say I add another child 4, and now I give it an order greater than 1. Let's say I give it a value of 2. So now child 4 will come right after child 2. So the order of the child elements that occurs in the format of increasing number of order. So all the elements which have low order number, they will come first, and all the elements having higher order number will come last. This is really helpful if you, in case you don't want to change the HTML, but you want to alter the ordering or the sequencing of the child elements using CSS. So you can use the order property for that. So this is pretty much what there is to Flex. Now, a rule of thumb is that you can create complicated website layouts with the concept of Flex, and in the further videos we will discuss how you can use Flex to kind of start thinking about different sections on the page and how you can use the properties of Flex and different values of the different Flex properties to kind of achieve the visual output that is there in the design. This kind of brings us to the end of Flexbox. There are of course a lot of playing around with it, and one of the most famous way of learning Flex is something called CSS Flexbox Froggy. So this is a game which is available on the internet, and the entire point of this game is to make sure that all of the frogs reach their respective home, and all you have to do is write down the CSS for this. So it has 24 levels from level 1 to level 24, and with each level you start off with an and with each level you actually go ahead and increase the difficulty in terms of the properties that you're going to use. So I would highly encourage that you go ahead and play this game. Try to cover up as many levels as you can. The link will be provided to you in the text file which is provided to you. So apart from this, you can start playing around with your own website that you created with in the previous module, and you can start using the concept of Flex to kind of visualize how different sections of the web page will get laid out. So we will discuss about the project, we will discuss about the thought process and a couple things more left in CSS. Till then, I will see you all in the next video.